Welcome back to Pachehra Talks in Artificial Intelligence series. Uh, Today we are going to talk about neural networks. In the previous one, in the previous video, we started generative AI. We had a very good example scenarios discussion in the previous video. And in today's video, we are going to explore or understand neural networks. If you do not remember, let me re let me say it again, what neural networks is, just for the sake of this video. But if you're following the series, you already know. Why? Because the heart of an AI system is a model. The model that we choose. If you remember how exactly it works, data collection, right? Pre-processing, then choosing a model. So there are many types of models, but neural networks are particularly popular for generative task, and this is what we are learning, generative AI. And these models are inspired by the human brain and consist of layers of neurons, or just like the human brain does, so that it can learn the complex patterns. All right, so today we are going to explore the neural networks. Why? Because we are studying generative AI. Why? Because it is a part of AI, and generative AI is something that we want to understand, and it uses neural network kind of model, which is needed for generative AI. All right, so I think we are ready to explore neural network, and we have basic premises already. So what is neural network? We already know it's a model, type of model for generative task. And let's see the structure of neural networks. What is the basic structure of neural networks? This is what we need to understand first. What is the basic structure of neural networks? So first of all, this neural network in AI is a computational model. But that's what models does. So it's a computational model inspired by the structure and the function of human brains that we already uh, said. So it is designed to simulate the way humans learn, making it a powerful tool for machine learning and AI applications. That too specific to generative AI. I think I have said many times, but now let's break down or explore what is a neural network, the basic structure, and how exactly it works. I'm repeating a lot of things a lot of time just because it should sink in, right, with everyone. All right, so what is the basic structure? Well, the very first thing, it is a layered structure. Okay, it is a layered structure where we have different layers. Layers like what? Like input layer, as the name says, that's what it does. Input layer, and we'll talk about uh, these layers as well. And then we have hidden layers. It has multiple layers, that's why hidden layers. And then finally, what would happen? Some output would happen, right? So there is an output layer. Now, we got its layers, but it's layers of what? Well, if you remember neural network, human brain, so it must be a layer of neurons. That is a correct answer. Neurons. It's a layer of neurons. All right. Okay, if this neural network is a layered structure which has multiple layers, and these layers are of neurons, what exactly the neurons? How would you define neurons in this neural network of Gen AI? Well, at the core of neural network, or the basic unit, is the neurons or nodes. You could also say nodes. which are inspired by the neurons in the human brain. And each neuron, it could have multiple neurons in each layer, and each neuron receives input, process it, and passes on it or output to the next layer of neurons. Okay, so it's a unit of processing, you could say. It's a unit. We are calling it neuron because it is inspired from the human brain. You could also call it node. It's interconnected nodes and these multi layers, and these nodes receive input, process it, and passes on its output to the next layer of neurons. So that's what the neuron is. Okay, that's how the structure is. All right, so we understood these layers are of neurons, and neurons is the unit which receives input, process it, and output to the next layer. All right, so what exactly this input layer does then? What exactly this input layer does? Well, it receives the initial data for processing. All right, all these layers are made up of neurons, so that's why I put it uh, here. Let me put it here because first we should have neuron. These layer are the neurons layer, right? So we can put it here as well. This is neuron, and these are the layers. Okay, so input layer, it receives the input. All right. uh, how? Through neurons. Why? For processing. Initial data for processing, we could say like this: initial data for processing. All right, so what happens in the hidden layers, or you could also call them intermediate layers because it is in between input and output. So that process the inputs received from the previous layer using weights and biases. Now you must be wondering what is weights and biases. Weights is just like you gave, let's suppose it's 80%, 70%, 60%. The correction, right? Weights, and the biases, so that AI can learn. All right. You could also say the parameters that indicate the importance of each unit is the weight. All right. And what would be the biases? It would be an additional parameter that allows adjusting the output along with the weighted sum of inputs. This is where the learning, the decision is happening with all the data which is coming in, right? The intermediate layer, it process the inputs from the previous layer, and now it uses the weights and biases and learn the structure. Now it is started learning the structure because this is not human brain, it learns on the numbers, numerical values. So that's how it is started learning, and these layers perform complex computation and features extractions. And this hidden layer is giving weights for each feature or each what do you say, dimension of structure that is going through, and the biases, of course. And what happens in the output layer? Well, it produces the final output of the neural network, such as class label. If you remember label, there was the classification task, or a continuous value was a regression task. So the kind of output we are uh, looking for, the same kind of output it will provide to us as the output of the neural network. If it is a classification task, then it would be a label, and if it is a continuous value, then it would be regression. All right, so the basic structure is kind of clear to us now. So what's next? Well, well, we need to understand how exactly it works. That is not clear yet. All right, then. If that part is not clear, let me put this and let me get this thing here. How exactly it works. This is our main riddle that we need to solve. Now we know the structure. Now how it works, the learning, the training, the prediction, everything will start from here and output will come here. But during this, what happens? Let's see that. And what is the right way to understand that? We should take an example or maybe a scenario. Let's take a scenario of a uh, mobile app. Okay, let's take an example of mobile app. What it does, it predicts. Simple enough to understand what it is predicting the movie you like. How? On the basis of your past movie ratings. Okay. All right. That seems easy enough to understand and interesting too. So imagine mobile app that recommends movie. It uses what neural networks to predict how much you would like a new movie based on your ratings of movies you have already seen. Why we need ratings that we have already seen? Because it how it works. Remember the data collection, because it needs data to see, to understand the pattern and the structure and learn and then give the output. So the very first step would be, we call it forward propagation. Forward propagation. That's what it is. This is our step number one. What happens here? Well, we need to input our ratings for several movies into this app. Okay. Each rating is fed into the input layer of the neural network. All right. The data is processing. We need data. Data is our ratings. As the data travels through the hidden layers, these are the hidden layers. Each neuron process the inputs, which is your ratings, using weights. Remember that weight signifying the importance of each rating for predicting your preferences, and biases, kind of adjustment factor. That is the bias. All right. So then let's think of each neuron in a hidden layer as a focusing on different aspect of your movie preferences. All right. Still with me? Right? It making sense now? Yeah. One might weight heavily on whether the movie is a comedy or not, another on the presence of a favorite actor, or another on the movie's length. Each neuron processes these factors based on the weights and biases, contributing to the network's overall prediction. You see how granular it goes? That's why neurons or nodes, multiple nodes, it's interconnected nodes. Each node is picking one of the feature, one of the criteria, and learning and putting weights and biases there. All right, so that is what is happening here. It is happening forward propagation. This is the forward propagation. Then we have second step. Once this is done, once each neuron process these factors based on the weights and biases contributing to the neural network, then the second step happens, which is activation functions. What is this? This is activation functions. As the name says, what happens? What happens here? Neurons use activation functions to decide whether and how much to activate or contribute to the network's next layer based on the input they receive. Here, the activation is happening. Here, the decision is making. So, how this will relate with our example? Well, a neuron that processes whether you like comedies might use an activation function to strongly activate, indicating a high preference for comedies. If you have rated comedies highly in the past, if you haven't, it might barely activate, right? This is what is happening. The activation is on which, what preference you activated, your mind activated. You like comedy movie, you got activated. You like action movie, you got activated. So this process allows the network to handle complex relationships and non-linear pattern. That is the keyword, non-linear patterns in your movie preferences. That's what is activating it. Okay, so here it is getting more structured. Then the third step is in this is learning process. Okay, now it will start learning because we have pre-processed the data, the things we have, and we also activated. So on that, it will back propagate. What is back propagation? Well, after the network makes a prediction, a rating you would give a new movie, right? That's the prediction. It compares this prediction to the actual rating you gave, if we already have, and that's the idea, like we already have. So the difference or error is calculated using a loss function. The network then uses back propagation to adjust the weights and biases to reduce the error. Remember, the weights and biases were happening where? In the forward propagation. Here, the weights and biases were settling down. In the next, it will started activating function, or you could say uh, how much to activate, right? And then in the learning process, what it is doing, it start adjusting the weights and biases as per the learning, as per the practice, as per the predictions. All right, because whatever is happening in the forward propagation is you cannot say like it is always right. It's just a process. It is going. It's keep on gradually increasing and getting better, which is happening in the learning process. Now, suppose the app predicts you'll rate a new comedy 9 out of 10, but you rate it 6 out of 10. The network uses this error to adjust its parameters. So next time it might predict more conservatively for similar movies, refining its understanding of your preferences. Okay. So weights and biases got adjusted. Now, finally, after the learning process, what would happen? It will training, getting efficient. So this cycle of making predictions, comparing them to actual ratings, calculating the loss, and adjusting the network's parameters through back propagation is repeated many times in many different movies and your ratings and getting better. So over time, as you rate movies, the app gets better at predicting your movie preferences. It's like a friend who knows you better with each movie night, learning more about what you enjoy and making better recommendations. So that's how it actually works in these four steps. Okay. Now, in this example, the neural networks in this movie recommendation, movie recommendations app learns to predict how much you like a movie based on your past ratings through forward propagation, activation functions, back propagation or learning process, and repeated training. Okay, with lots of movies and rating, it gets increasingly better and at understanding your preferences, similar to how a friend learns your test over time, right? Okay, now we should take another example which will help us to cement the knowledge. And this time, it's we are not going to predict movie, but we are going to predict something else. And what is that? Let's predict cat and dog. Simple, easy, and who doesn't like cat or dog? All right, let's do, or maybe forget the dog for now. Let's do cat photo identifier. Make it more simple. Identifier, if I'm spelling it correctly. That's what we're gonna do. So imagine you have developed a simple neural network to determine whether photos uploaded to a social media uh, platform contain a cat. This task involves classifying the photos into two categories, cat or no cat. What was it? Classification, right? So uh, the very first thing was forward propagation. So what happens here? Users upload photos. Each photo is converted into numerical format. You remember why? Because it doesn't understand the language the way human does. It's a machine. It it understands through numerical format. So and fed into the input layer of the neural network, the data then passes through the hidden layers or intermediate layers. So if we Apply this logic on our example. Think of each neuron in the hidden layers as asking a specific question about the photo. For instance, one neuron might focus on detecting the presence of body hair. Body hair on what? On the animal. Another might look for two pointy ears, and another might check for fur patterns typical of cats. The outputs of these neurons based on the weighted sum of their inputs plus their biases are then passed on the next layer, because that's what is happening in the forward propagation, weighted and biases. So it will forward that to the next layer, which is activation function. What happens here? Each neuron in the hidden layers applies an activation function to its input to determine its output. This can introduce non-linearity, allowing the network to learn complex patterns. If the question about body hair results in a high value, animal body hair results in a high value, the activation function can amplify this signal, indicating strong evidence of a cat in the photo. Okay, that kind of hair, you could say, like in the photo it could be clear. If the value is low, the activation function can diminish the signal, indicating the absence of body hair. This process allows the network to handle the complex patterns, like recognizing a cat in various poses or lighting conditions, right? So if you remember in the mobile app that we have that predicts, neurons were getting activated or use activation function to decide whether or how much to activate, on the basis of what? If you remember, think. Comedies, there was example. If you have rated comedies highly in the past, or if you haven't, it might barely activate. If you have rated comedies highly, then it will activate highly, right? So that is activation function on which he has to choose. It will help you. It will activate that particular thing. Then the learning process. What happens here? After the initial forward pass, the network makes a prediction, cat or dog. This prediction is compared to the actual label, if the photo indeed contains a cat or not, and the difference, which is error, is calculated using a loss function. Suppose the network incorrectly identifies a dog as a cat. The error calculated from this incorrect prediction is then used to adjust the weights and biases, which were in the forward propagation. And this is like to telling the network this feature you thought was indicative of a cat actually isn't as reliable as you thought, prompting it to adjust its internal parameters accordingly. Then finally, training. This process of making predictions, calculating errors, and adjusting weights is repeated across many times, iterations with numerous photos, and it gets better and better and better. So, in this simplified scenario, the neural network learns to classify photos into cat or no cat by repeatedly analyzing examples, making predictions, and adjusting its internal parameters based on the accuracy of its predictions. This process, involving forward propagation, activation functions, back propagation or learning process, and repeated training, allows the network to improve over time, ultimately becoming proficient and at identifying photos containing cats. All right, so I think we are good now. We know the structure of neural network. It's this, and then we took the two example of 4 steps, how exactly it works. So if we need to conclude, the 4 steps: forward propagation, data is fed into the input layer and it travels through the hidden layers where the actual processing happens through weighted connections and biases. Simple enough. Now each neuron applies a specific function, which is activation function, to the input it receives to determine whether and how strongly to activate and pass data to the next layer. So these functions help the network learn complex patterns by introducing non-linearities into the model, allowing it to make sophisticated decisions. And learning process, the network learns through a process called back propagation, where it adjusts its weights and biases in response to the error in its output. The error is calculated by a loss function, which measures the difference between the network's predictions and the actual target values. And there is an optimization algorithm here which is used to minimize the loss function by adjusting the weights and biases. And finally, continuous improvement, which is training. The network is trained by repeatedly feeding its set of data forward, propagating and the data through the network, calculating the loss, and then back propagating the error to adjust the weights. The process is repeated across many times. And finally, you have very efficient generative AI. Well, I hope it was informative and you learned something new today. Well, thank you for watching, and you guys have a wonderful day.